Greetings, Mr. Lee here. We're going to compare some linear functions today. So if you think about your slope-intercept form, we have your two main features, slope and y-intercept. And the comparing is going to happen between two different functions at a time. Okay, so here's example number one. Function one is defined by the table. Function two is defined by this graph. And the main question is, which function has a greater y-intercept? Okay, so read the question carefully all the way at the bottom. We don't have to extract all the information. We just need, for this one, figure out what the y-intercepts are and then figure out which one's bigger. Okay, so for the table, remember your y-intercepts happen when your x value is 0. So this is your y-intercept, -6. Okay, I'll go ahead and write that down. For the first function, that's represented by a table, you have a y-intercept of -6. The second function, represented by the graph, you should be able to see that we have a -7. Okay, so just compare the two numbers. -6 compared to -7. Obviously, -6 is bigger. So we say function 1 has a greater y-intercept. And that's my dog. All right, next question. Function 1 is defined by the equation. Remember, we have those three representations, right? Equation, table, graph. So this one's an equation. We have a slope of 7/2. Y-intercept is -3. Function 2 is defined by the graph. Let's take a look at the question. It's another y-intercept question. Okay, so let's extract the b value from the slope-intercept form. So my y-intercept is just a -3 here. It's my b value. Don't confuse it in this example with the slope. We just want the y-intercept. And then my y-intercept on function 2, represented by the graph, is also a -3. Okay, so that means these two functions, even though they're different, they do have the same y-intercept. Let's see if we can get an example with some slope comparison here. Okay, so here's a good one. I kind of started at the bottom. That's where my screen was. Which function has a greater slope? So let's go to the top now. Function 1 is represented by the table. Function 2 by the graph. Okay, so your definition of slope, change in y or change in x, right? Rate of change. Let's figure out what that is. I'm going to choose these last 2 points just because I don't have any decimals here. So if I go from 14 to 17 in the change in y, that's +3. 4 to 6 is a +2 in the x direction. So change in y is 3. Change in x is 2. I have a slope of 3/2. Okay. If it helps you, you can run on the calculator. 3/2 is also 1.5. Okay, that might be easier in some cases to compare the slope values. Okay, so that's my table, function 1, slope value of 1.5. In function 2, what do we have? We got to pick two nice points here. Let's just choose the y-intercept and then the next nice point to the right. So that's going to go what? Up 2, right 1. Up 2, right 1. 2 over 1 obviously is going to be 2. Okay, so which one's bigger? We have function 2 with a slope of 2, function 1 with a slope of 1.5. Therefore, function 2 has a greater slope value. Done.